that basically involves the tip to tail rule, the graphical method, or tip to tail rule. So basically, whenever in Cambridge the command word in the question used is sketch, okay, sketch and complete or sketch and draw, to find the resultant velocity or force, we use this method. Now, it is not necessary that they will use a command word. Sometimes they can also say, find the resultant vector. So if they don't use the command word sketch or they don't use the command word calculate, so we have a choice whether to use the mathematical method or we use the graphical method. And if we have a choice, then I will always recommend that you go for the mathematical method because it doesn't involve sketching or scaling. You do not need to scale for the method which is the mathematical method. So the same question that basically we so basically the same question that we had done by the mathematical method, this was the question I'm pasting, in which a ship is sailing 92 meter per second east and wind is blowing 24 meter per second north. We had to calculate and find the resultant velocity, magnitude and direction, considering 10 meter per second being 1 centimeter. Now, instead of calculate, they can say sketch and find, okay? So if they use the command word sketch, again, I'm gonna reiterate that when it says sketch and command word, then you will always be using the concept where we use the tip to tail rule. So sometimes they will give the scale in the question like they did in this past paper question. Sometimes they will not. Now we cannot represent 92 meter per second or any force on the paper unless we only can draw lines. So if 10 meter per second is 1 centimeter, then 92 meter per second means it is 9.2 centimeter, okay? And 24 meter per second will mean that it is basically 2.4 centimeter, okay? Now, if basically we have these two, then we also know the directions which are given over here. 92 meter per second is east and 24 meter per second is basically north over here, okay? So it doesn't matter which one I draw first, okay? I can draw the east one or the north one, but the rule is to draw tip to tail. Excuse me. So you are going to use your foot rulers, the scales, the rulers that you have, okay? That one you will use, and you will first create a 9.2 centimeter line on your paper, okay? And I will always recommend drawing the arrows in the middle maybe instead of at the end, because if you draw it at the end, you may extend the line by mistake. So draw a line whenever you will be doing this question, you draw a line of 9.2 centimeters, and then you draw the arrow, okay? So now what I do is that from the tip of the first vector, I'm going to draw the tail of the second vector, because 2.4 meter per second was north. So from the tip, this is called the tip, the arrowhead, we will draw 2.4 centimeter. So this is basically the line of 2.4, and the lower one is the line of 9.2. This is called tip to tail because you join the tip of the first vector with the tail of the second vector. Then after you have drawn this triangle, you are going to join this line's the first vector's tail to the final vector's tip, and the arrow will be in this direction. The arrows in the vectors must be drawn very carefully, that the answer is going to be from the tail of the first till the tip of the last. Now with the foot ruler, you will place the foot ruler next to this line that you will draw, and you will take the reading using a foot rule. And when you are going to find the reading, then what you do is that, for example, the foot ruler is showing me as an example. I'm saying it shows me 9 point maybe 5 centimeter. Okay, so this is going to be basically my resultant velocity magnitude, but it is in centimeters, so I have to convert it back. So because it is already given to us in the question that 1 centimeter is 10 meter per second, this means 9.5 centimeter will be 95 meter per second. So basically the magnitude that I found of my velocity, magnitude means the number, the amount, the quantity, that is going to be 95 meter per second. But another thing that remains is the direction. The direction you have to find using an instrument or a geometry box instrument called a protractor or a D. And excuse me, what you're gonna do is you will be basically putting the protractor in such a manner that you want to measure this angle. If you want to measure this angle, you will make sure that the two lines that I'm highlighting in blue, these two are within the protractor. So I would put my protractor in this manner, and wherever these two lines meet, the plus sign of the D meets there. This is my protractor D. Okay, so basically then you will measure the angle from 0 and here. Okay, for example, it comes out to be 32, for example, it comes out to be 14.8 degrees on my protractor. So this is with the x-axis. So we will have to measure or write the direction 14.8 with x-axis. That is going to give us the final resultant answer of this complete